started. This is Intro to iOS Development. This is our first lecture for this semester. We're going to go into just brief introductions. My name is Yana. I'm currently a junior studying computer science in the College of Engineering. I joined AppDev as an iOS developer my sophomore fall, and then I was working on Ithaca Transit for a little bit, and then Uplift for a little bit, and I'm working on a new app that we're working on this semester.
What's up, everyone? Can everyone hear me well? Okay, good. My name is Omar Rashid. I'm a junior studying CS. I joined AppDev the same semester, so sophomore fall, so about a year and a half ago. I also started off working on Ithaca Transit as an iOS developer, and I am also going to be working on the same pod chat, a new app we're developing this semester.
All right, so we have a lovely set of TAs here. We have a couple here. We got Gonzalo and Matthew Scullin. I don't know if anyone else is here somewhere. Oh, we have William in the back. But yeah, they'll be holding office hours, grading your assignments, answering your Piazza questions, so we're really thankful to have them. And just some logistics before we get started with the lecture material. Our lectures will be every Monday, excluding like February break and spring break, 7:30 to 8:30 in Gage GO1. We're going to have weekly office hours, which we'll figure out at the end of class, so we'll take a survey to figure out like when you guys would prefer to have your office hours. We're going to be using Piazza for all course communication. You can just look up CS 1998 section 602, or when we post these slides later, you can just click on that link. We have a new course website this semester. The link is right there for you guys to go to. The syllabus is up there. All assignments, lectures, the demo starter code, and other resources will be uploaded there. And then just like a final note on academic integrity, this isn't like your traditional class taught by a Cornell professor, but we do have to uphold all the Cornell academic integrity standards. So if you filled out the Google form that was like our application for this course, there were instructions in there on how to enroll in the course. The deadline to add is March 18th, and you can just do this directly on Student Center. Once again, the course number is 1998, section 602, and please enroll for 2 credits, so you have to select the little drop down next to units and switch it to 2, and do it satisfactory, unsatisfactory. Our only tip is if you would be over your credit limit, you can enroll in only 1 credit, but we're still going to grade you as if you were taking the class for 2 credits. And then just basic requirements. I think looking at the responses to the application, most of you had some introductory programming experience or are currently taking CS 1110, so that's perfectly fine. Unfortunately, you do need Mac OS to be taking part in the class because Xcode will only run on Mac OS. So we've had little success with people on VMs in recent semesters. There's an installation guide linked in the slides, but a lot of people were having issues with it last semester. So it's definitely preferable if you're just running Mac OS natively. And then once you have that, you can just download Xcode off of the App Store directly.
So I guess we can get started on the iOS part. How exactly do you make iOS apps? So who here has heard of Swift or used Swift at all? Some people, actually quite a bit. Swift is one of the 2 native languages we use to build iOS apps. Swift is simple, expressive, fast, and it's fairly simple to use. And have people used Objective-C at all? Yeah, I personally find it disgusting. It has a lot of brackets. Swift is a lot simpler, and you'll see an example right here. Wait, my cursor doesn't work. But yeah, so you can see here, this is how we declare a very simple, variable called myString. Just contains its own string, and then you want to uppercase it, so you just call it uppercase function. I assume most people have done Python, and so it looks very similar in syntax-wise. And then you see the Objective-C comparison. You have to create a pointer to a string object, and then wrap it with this @ sign. It's got a lot of weird syntax, but yeah, we'll go through a lot more syntactical stuff later today. And then Xcode is the thing we mentioned that you have to download. It's pretty much the IDE for building out iOS apps. If you use VS Code, Sublime Text, it's very similar, except it's catered a lot towards iOS development. And so like you'll have a simulator in there, and you'll pretty much be running everything we do here. And so we have a quick demo on Swift Playground. Let me pull it up. We actually have this demo, like the starter code, linked on the website if you guys want to take a minute to download it. I'm not sure. But we have the website linked up here. I'll leave it up for like a hot sec. If anyone wants to download it, you can go straight to like lecture 1 demo and download it. And then if you guys have Xcode running, then it should be very quick to get started. But yeah, I'll leave it for a few more seconds. What?
Go to the
Oh,
link.
I should probably just go to the link. Dope. Well, where's my...
There's a button that says.
It's okay. Oh, I already have it open. Yeah, just go to lecture demo. Click this thing. I'll download it. But yeah, I guess we can get started. Is this the right one? Okay. So yeah, first things first. Can everyone see?
Font.
Oh, I should definitely make this bigger. Hello. Is this good for everyone? All right, I see some nods. We'll go with it. So yeah, I guess to begin with, we have two, I guess, different ways of creating variables. You can create either a constant variable, which is immutable, and then a regular variable, which you can change throughout the context. And so the syntax for that is let, and then your variable name, and then whatever you want to assign to it. So if you want to create a very simple string for a net ID, this is the syntax to do that. Notice that we use, actually, okay, we'll go through. We also have a variable, very similar. You can assign like any simple like types to it, another string. But one thing we want to note here is the difference between let and var. So any let variables that we create, we cannot change at all. So if we wanted to assign net ID to something new, let's say OIR2, this will eventually give us an error. Yeah, so cannot assign to another value. And so that's because the let variable, or a let is a constant, and so therefore is immutable. But if we wanted to do the same thing for simple string, something different, this will not throw us any errors. So you can change your variable around, similar to how you can do in Python with any variables in there. Also, another thing you notice that we don't have to specify any types, although you can for variables. So here, for example, we have for full name, you want to specify that it's a string. Same thing for month, integer. And then UI label, this is more UI related stuff we'll go through in following lectures. But one thing is you cannot change the type after it's already been assigned. So even for the ones where we don't declare a type like explicitly, you can't change them. So like if we tried to do a simple string equals 1, this is gonna give us an error. I hope so. Yeah. And same thing down here. Actually, we'll keep this example down here. This is not gonna allow us to do this, as it'll give us an error because we're trying to assign it to a different type. Yeah. I guess we can go through simple printing. I believe. Oh wait, what the hell? How do we print? Print, right? Dope. Yeah. So if I wanted to print, Omar is cool. How do I run this thing? Hello. Oh, dope. There's a play button. Sorry. What the?
Thing.
Oh, is this gonna run? Please file a bug. What? Report a bug. Bruh, why is this not working? Hello? Stop. Go. Bruh, this shit should work. Alright, so it's not working right now, but I promise you print works. Oh, there we go. It finally worked. I told you it works. So we can also use some nifty Swift syntax that we have for, let's say we had like some variable, some variable that represents our age, and we wanted to print out Omar is age years old, right? So one way we would do that is use this cool little syntax to just add in the variables. So usually you would, I guess what's a little more recognizable to people is that you would do this. Oh, that's not what I want. But one equivalent to this is that we would instead just use this syntax, and it would just plug in the variable in the same exact place. So, oh, hello. Is this gonna work? Hello. Okay, dope. Let's hope that these actually run too. Perfect. All right, yeah. So you can see these do the same exact thing. This syntax is preferable. It's a lot cleaner, a lot simpler. Will keep your code more organized. But yeah, okay. Let's get started on arrays. I guess if you've gone through 1110, these should be somewhat recognizable. So I guess this is syntax to create an initialize an empty array. You do have to specify the type if you're going to just do an empty array, considering we can't change the types after it's already been initialized. And so yeah, this is just syntax for how you create an empty like int array. And then let's say we want to add to this array, so like lecture numbers dot append. That's how you would append an extra element on there. But as we said before, the types can't be changing throughout your code. And so like let's say we want to somehow add in a string in there. Doesn't work. This is not gonna work, I promise you. Yeah, so you have to make sure that you're keeping the same types throughout your entire code, especially for arrays. Some other cool syntax for a for loop. Yeah, so it's just like for whatever you want each. It's like I don't know, whatever variable is going to be like used throughout each of the blocks in your for loop, and then in whatever the range you want to go through. And so this is simple Swift syntax for range from 1 to 10 exclusively. So like 1 to 9 if you want to. I think this works. I'm not sure. We won't do that. But yeah, so this is how you would create a simple like range. This would basically create a list of elements 1, 2, 3, 4, all the way until 9, and would insert it into here. And then every single block of the for loop, it would append to lecture numbers. And so if we run up until here, and if we print out lecture numbers, oh, this is lecture number, yeah, dope. Oh, this is syntax. Oh, cool. Oh, we appended one up here. Let me get this out of here. Yeah, so we have this list of 1 all the way to 9. And if we want to do it inclusively, so we include that last number, this syntax for that. Oh, we probably have these. Oh, fuck. Lecture number is 2. We have 1 to 10 as it's inclusive. So it's just like small syntax for creating ranges, like very quick lists, or whatever range of numbers you want to do. We already printed these out. Dope. We can print them again. That'll be cool. But yeah, the first one prints out 1 to 9. The next one prints out 1 to 10. But now we want to remove from this array, right? And so first we have our first one. Let's say we want to remove this number 1. How we would do that is we would do dot remove, and then we specify the index that we want to remove at. So let's say we want to remove the number 5. Who can tell me which index we would remove at? Who? Someone? Anyone? I heard a 4. I hope you were going to say 4, because it's 4. So yeah, we'll see here that we remove that number 5. But let's say we want to remove from an array that does not have any elements. What do you think is going to happen? So yeah, we just created this like empty array, and we try to remove at index 0. First, let's print it and see what's in here. Oh, what the? Okay. All right, let's print it. It's an empty array. What's gonna happen when we remove at 0? It's gonna throw us an error. See, this would crash your app, so we do not want that. But yeah, that would not work. I think we can do it. There's like some other cool syntax with remove. You can also just remove all, remove first. There's a lot of cool stuff you can do with this. You can specify like a condition for it to pass or remove all the elements that pass the condition. It's a lot of cool stuff. So yeah, let's say you want to modify a specific index of an array. So like similar to Python, you would just index into the array and change up like whatever value. Also keep in mind the types still have to be the same. So it would not work if we try and assign this to 1, considering this is an array of strings. See, it'll give us the same issue. And so if we first print this out, we'll see. Oh, we gotta comment this out. Peace. So like we first have this array of Kevin and Mindy, and then if we want to change it to be Yana and Matthew, we simply just index into it and assign it to a new value. So yeah, now it's equal to Yana and Matthew. But what if we try to index into an index that does not exist? So we have an array of length 2, so that means we only have indexes 0 and 1. If we try and index into 2, it'll just crash again. Index out of range, and so you want to ensure that you are indexing into a valid location into your array. And so yeah, if you're just trying to add it to the end, then you just append. It actually works. Print course instructors. Dope. It's in there. Now, dictionaries. A little more interesting. Also very similar to Python, except you still have the type constraints of that. The keys have to be consistent, and the values and keys don't have to be the same type. They just always have to be consistent. And so yeah, if we have a very simple dictionary right here, this is strings to ints, and so let's like say this is a basket that's holding a bunch of stuff for your picnic or whatever. Here's how we would iterate through a dictionary. You can break up each key value pairing. So you would have the food and the quantity in your pantry. And we'll just simply print them out here. We have similar functions for these. So like let's say we wanted to add into pantry. Or if we wanted to change whatever is at apples, we could assign it to a new value. Pantry. Actually, can we just print this out? I think so. Yeah, so you'll see that we updated the value here. But again, same constraints with the types. This will throw us an error. I'm really trying to drive this type constraints home because it'll cause a lot of problems down the line. Okay, now onto the function syntax. Also very similar to Python. I think Python is just def. Yeah, I haven't used Python in a while. But yeah, it's like def, whatever the name of the function you want, brackets. If you want to have any variables in it, we'll go into that in a hot sec. But yeah, if you like want to call this function, simply call it with the parentheses. If you want to pass in arguments, let's say print var, and you want to pass in a variable, let's say we want it to be a string, and we print out v. So the way this is how you would declare it. This would be the variable that you would be passing into your function. You would assign it a type, and then you can call that variable as like, this is the function that you're passing into whatever call you are making to this function. And then if you want to call it, you just pass in whatever Yana. And then if we call this, it'll print out Yana. And return type. Dope. Also, sometimes you can print out, or if you're trying to return a value from your function, so like let's say we have a function called add, and we wanted to add two integers together. I guess let's poll the room. How do you think we would do this? Eason, I know you have an answer. Okay. Okay, we would just have, okay, variable 1, it would have to be an integer, right? Because we want to, oh, dope, you have an answer. That's correct. Right. And so in the code here, you would just return variable 1 plus variable 2. And so to go over syntax, so yeah, this is passing in variables into your function. This is how you would specify what kind of return value or return type you would have out of this function. So this function would return us the sum of two integers, and it would also be an int. And so you have to manually specify that. I believe so. And then within the function, you have to make sure that you have a return statement. If we did not do this, and let's say we wanted to just print out variable 1 plus variable 2, this will shout at you, I hope, saying that we don't have a return expression. And so yeah, it just will not let you run this code. And then let's say we wanted to, we're just gonna change these to variable 2. And so if we wanted to call and store the result of this function, this is how we would do that. You would create a let. It could be let or var, although Swift will tend to shout at you if you're creating a variable using var but not changing it, because considering it could just be like a constant, there's no reason to, I guess, like potentially change it down the line. And if we want to print out the result, it should be 5. It's 2 plus 3, right? Cool. All right. So we'll move on to structures and classes. So are people familiar with classes, Python, object-oriented programming in general? I see not too many nods. So okay. So pretty much like what a struct or a class is it's an object that gets stored in your like memory, and it wraps several different variables, and like pretty much you get to organize whatever kind of objects you want to use throughout your code. And so let's say we were designing like an app for what if we were designing like Netflix, and we wanted to organize like some way to represent like episodes and TV shows and all this stuff. And so one thing we would do is we would create a class to represent this entire object. And so for example, our episode object, we would have a name and a duration. Obviously you'll have a lot more stuff, but for now this is good enough. And so the way we would create the definition, or like the model of how this episode will be like created, is this syntax. You would create a struct, give it a name, and then all the variables that come inside of it. You can also create functions within it, but we don't have to deal with that for now. And this is how you would instantiate it. So you could create episode 1, you would give it a name and duration. Same thing for episode 2. Actually, let's just print these out. I don't know what happens if you print them out. Dope. It has all the information that's stored within it. And so an alternative to this is creating a class definition or declaration. So like first we had struct and we had class. Very similar structure, except you have to specify an initializer. Actually, is this even true? Do you have to do this? Is this gonna shadow me? Yeah, it's gonna shadow me. You can also have functions in here. This can exist for this as well, but we won't do that. Yeah.
And structs and classes, do you need to have type annotation for the variables inside the struct?
So you do if you're not going to initialize it. And so like let's say we wanted to create, I hope this is answering the question, but like let's say we wanted to create like a placeholder, and we wanted to just keep it as 1. You don't have to explicitly say that it's an int.
Also, if I don't like assign it anything, I need to declare its type. Okay.
Right, yeah, because this is kind of just like the outline or the blueprint of how you're going to like create these instances later. And so you're making sure that every single time someone creates it with a name and a duration, the name has a string and the duration has a float. That's a good question. And so yeah, you also create an instance same way. But now we have a very big difference between classes and structs. So far, the syntax for it has been very, very similar. But the way we deal with, I guess the biggest difference between classes and structs is that structs are value types and classes are reference types. Has anyone dealt with like C language before, pointers and stuff like that? So yeah, I guess the idea of it is that when you create an instance of a class, what's stored in your, I guess the variable, so like let's say in here, what's stored in here is a pointer to an object that's stored in memory. And so let's say we want to, I'm going off script, but this works. It's fine. But like let's say we wanted to change the value of our name. This is what's happening is that it's going into the location that's stored at this variable and it's changing the object that's like stored in memory. And so like let's say we wanted to print out this new product or podcast. It's going to change, but hello? All right. Okay, so that's actually one big difference. You'll see here that when we printed out the episode, it gave us the entire object, which is the value that it represents. But when we printed out the podcast, it gives us like a weird string that probably represents this location. I don't actually know what it represents, but it's weird. And so the biggest difference that you see between class and structs is that if I want to assign, let's say we want to do podcast 2, and we wanted to copy all of the values of podcast 1, but we want to change the name of podcast 1 to be intermediate iOS. What'll happen is that because they're both pointing to the same location in memory, they'll end up changing the same value. And so when we change podcast 1's name, we're going to effectively be changing the name of the object that podcast 2 is looking at. And so if we print out podcast 1.name, and we print out podcast 2.name, they will both have the same value. Hopefully. Yeah. It'll be this change value, which may not be I guess it depends on how you want to implement your code, but what happens differently with structs is that when you're assigning all of it, because it's a value type, all of the values that are stored within the struct get copied over when you're assigning it. And so we'll see here, we have the same thing. Dope. Yeah, so here we created an episode and it has a duration of 5. We called it structs, and then we created a fourth, I guess, episode. And we gave it the same values as 3. And if we print out episode 4.duration, or we can just print out the whole thing, honestly. You'll see that the values do not change, or like they don't persist across different instances, because when we made this definition, the values got immediately copied over and they're 2 different objects. Yeah.
So even in classes, if you were to do like, say this is a class, and you did episode 4 duration gets 14.3, then it would also change episode 3.
Mm-hmm.
It has to be the original object that you're changing, or the original class object.
If you're assigning, like if we have this assignment, actually, yeah, we have this. Invalid redeclaration. It's because I created this one. So yeah, if we have this assignment right here, with between 2 classes, then whenever we modify podcast 3, we're going to be modifying the same object that podcast 2 points to, and vice versa. But if we were to create like podcast 4, 34, dope. Podcast, and we create it with like something completely different, then obviously like whenever we modify podcast 3 and podcast 2, we will not be modifying podcast 4. Um,
So
podcast 2 and podcast 3, yeah. Yeah, what's up?
Are there publics and private?
There are. Yeah, we can. Do we even? Yeah. So I guess within the class definition, if you wanted to restrict, like, let's say, nobody who's like accessing this class outside of this file can change it, then we can just create name as a private variable, and this will make it so that the only time you can ever change name is within a function that's within the class definition. That's a good point. Yeah, what's up?
Beyond the interaction of like copying multiple instances of an object, are there more differences between structs and classes?
I guess it's just the inherent notion of them being value type versus reference type. Um, I guess anything to add to that?
Classes
Yeah, I'm not-
need an initializer.
Yeah, classes do need an explicit initializer. It doesn't inherit or like assume one. I guess, yeah, just small syntax stuff, but for the most part it's just like the concept of classes and the variables that like initialize classes are reference types rather than value types. Oh, what did I do? Oh, yeah, so you'll see here when we change this to private, we couldn't change or access the name variable outside due to private stuff. We're going to take this out. Where is this stuff? Oh, this is stuff we added. So another cool thing that we have with Swift is the concept of optionals. And so this is something I do not believe is in Python, or at least explicitly is not in Python. But what an optional is pretty much like if you have a variable that sometimes can exist as null and sometimes can exist with a value, this is pretty much a perfect way to, I guess, handle that. So we've dealt with like if we want to create a variable that takes in a string or is just represents a string. But if we want to say that it's optional, it can sometimes not be there or be represented by nil, then you would add this question mark at the end of the type declaration. And this pretty much just says like this can also take on the value of nil. And so if we try to assign a regular string to nil, this will throw us an error because nil does not conform to string. But here we can do that as it's a valid declaration. And the way we tend to handle these in code is a little different. Because like if you're expecting, let's say you have another string where I concat, and it's like the combination of this string plus your input string. Because we've declared input string as like it will for sure be a string, it's not an optional. This is a valid because like you can always assume that this will output a string. But if we have an optional, then this string is not always gonna output a string per se, as this can sometimes be no. This with string specifically, it's a little different because they have like some workarounds within Swift. But yeah, so to deal with optionals, you can technically check if an optional is not nil. And the way you would force unwrap or like get the value that's stored within the optional is to put an exclamation mark after it. And so this says I'm making the assumption that it is not nil and I'm trying to grab the value that's stored within it. But what do you think would happen if we try and unwrap a nil value? Or like, let's say we assign optional string to nil, and we try to print out the unwrapped version of optional string. What do you guys think would happen? Anyone? Any guesses?
Maybe hello world.
Hello world. That's a valid guess. I'll tell you, it will probably not do that. It'll actually crash. Oh, Wait, what the? Why is it not crashing? Hello? Oh, it's giving it error? What? Bro, what do I... what is this? Oh, no, that's not it either. Bro, this is supposed to crash. I promise you it's supposed to crash. Bro, what is all this? Oh, hello. Wait,
Scroll down.
no, it's because I declared it up here.
Alright, comment this out and this out. Just comment it all.
Alright, dope. Now we can try this example, hopefully. Where did I go? Oh my god. Please work. Oh, okay. Bro, I'm telling you this will crash. But oh, there we go. We finally got it to crash. Oh, but yeah. So this will not work because it's trying to unwrap and grab the string value that we declared here, but we have stored nil. So like this represents like nothing. And so yeah, whenever you're force unwrapping, which for most of the time you will like never ever force unwrap an object, but if you ever do, you want to make sure that there will always be a value in there. But a little safer way to do that is to use iflets and guardlets. And so what this syntax says is that basically you're saying if there's a value stored in optional string, unwrap it into this variable, and anything within this block is able to access this unwrapped variable as if it's just a regular string. And so unwrapped string you'll see has type string and there's no question mark, so it's not optional within the block. But one thing is, but you can't access unwrapped string out here. Yeah, it's just not a thing. But yeah, this is generally how we tend to deal with optionals. And so you'll see in here, we're able to print it out properly. Oh, wait, I still have this issue. We changed the value to be hello world. And since it hit in here, it does have a value, so it'll unwrap to unwrapped string. And then you'll see it printed out. The value wrapped in the optional string is hello world. Now, let's say we want to change it back to nil. What do you think would happen with this block? Any quick guesses? Nothing. That's a good answer, cause nothing will happen. Yeah. Oh wait, we should have put like another print statement. Nothing happened. Oh, yeah. See, like it never went inside this block because it saw that the value in optional string was nil. You can also just do an else statement and say print oh my god, optional string was nil. This would also be fine. You'll see that this block gets run if the value is nil. And so another way to deal with this is guardlets. So remember how I mentioned up here, like we're not able to access unwrapped string outside this block. And so we tend to use iflets if we have like a small case within the code that can like go either way. Let's say like we just handle if an integer or if an age is not filled out, then you just give a default value. Small like if statements here and there can work with iflets. But let's say a whole function, I guess depends on a variable being not nil. And it like sometimes can within your code, but within this function, you really need it to never be nil. You can guardlet, and what happens with a guardlet is that you're saying, doing the same optional like unwrapping, if there's a value within optional string, then unwrap it into unwrapped string. But you're saying if it's not, then this is basically like catch the case when it's nil, and you have to return from the function. And we'll go into this in a hot sec, but you can see that outside of this guardlet, you can still access unwrapped string. And so for the duration of, or like for the rest of this function, unwrapped string is you're able to access it and it's unwrapped as type string. And so if we change it back to we'll see two different instances of it. So if we pass in a nil for the optional string, here we just have a unwrap function. What it does is it takes in an optional string and it unwraps it, and it says like if it's nil, then the guard light returns out of the function and it just returns. Otherwise we print it. And so when we pass in nil, we'll see guard light returns out of the function. But if we pass in hello world, now I can use the unwrapped int, which has a value of hello world. And so for the rest of this function, you can do like unwrapped int. I don't know if we change this to var. Okay, so notice how we used to have like lets and vars, right? And so like let was a constant, variable is like a variable. You can change it. These also apply for if let. So like you can also do if var if you want to change the variable that you're unwrapping. Same thing for guard let. So you can change this to guard var, and you can then change it to something else. New string is and if we print out the second function, you'll see that we first had value of hello world, and then new string is something else. And so that we were able to do because we unwrapped it into a variable. Some other cool syntax we have is giving a default value to a variable. So like let's say we wanted to not really unwrap, but we wanted to assign this optional string to another variable, but we want to make sure that this other variable is not optional. Actually, we can explicitly type this as string. So how we would do that is basically what this syntax here is saying is that if optional string has a value in it and it has a string, assign it to this unwrapped string with default value, some long ass variable name. But if it is nil, then you just default it to whatever the default value is. And so what this will do is that I guess this is a way to unwrap, but I don't know, not really. But yeah, so we'll see here if we unwrap or if we end up with this variable storing default, unless optional string was somehow default as well, you'll notice that our unwrapped string was nil, and then otherwise it'll print out the actual value. And so at first it was nil. If we want to change it back to, actually we can just do this down here. Unwrap. Wait, where is it? Optional string. This would print out unwrapped strings value. This. Technically, we could mess with the code. And this will tell us that it was no, but that's wrong. So we can also just print this directly, considering this is of type regular string, and it won't give us any issues. Default. I'll change this back to something else. And then we also mentioned the force unwrapping. Oh, wow, I was way ahead of, okay. But yeah, so when we force unwrap, we have to, like we mentioned, we have to ensure that it's there. If we try and force unwrap something else, it's gonna give us an error. We already went through this, so this is cool. So now back to dictionaries. Dictionaries can also store optionals. Pretty much like all the structures we use can store optionals. So structs, classes, arrays, dictionaries, anything else you can think of, optionals are most probably, or they are like allowed. And so let's say we had our pantry. Wait, where is this pantry defined? Dope. I'm gonna move this down here, just so we have it. Where is? I don't like that it's all the way up here. Where did I redeclare it? Fuck. Dope. So let's say we wanted to I guess one thing is, let's say we had this empty dictionary and we want to try and grab the value that's paired with our key pairs. But we don't know whether or not it'll exist. And so technically if a key value pairing doesn't exist, then the keys pair is nil. And so what do you think will happen here if we try and force unwrap a key that does not exist in our dictionary? It'll throw us an error. I hope so. Okay, yeah. And so it's gonna crash because we never actually added pairs into our dictionary. But we can use the if-let syntax to like optionally unwrap pairs. And so let's say we like don't know if it's in there, but if it is, then we want to run some code. Then we can use this if-let. But let's actually add values into this now. Actually, we'll do it under this. And we'll do apples. We went over this syntax, I think. Apples equals 1, and then pantry. Oranges equals 0, because we don't like those. So if we try and if-let or unwrap the pairs, then we'll see that nothing will print because we still don't have any in there. But if we unwrap apples, then we will have it. I have 1 apples. That's wrong. Now, another thing we have in here, we have enums. Has anyone used enums before? It's like kind of a weird structure, like object. So I don't know how else would I describe an enum. Pretty much like if you want to declare, so like a good example we have is like, let's say we have like 3 different font sizes, just small, medium, and large. Technically you could like have some key that you guys like write down on a piece of paper saying like the number 1 maps to small, number 2 maps to medium, or you can use like strings. But I guess a good and efficient way to represent them within your code is to use an enum. And so I guess this is quick syntax for creating one. And so let's say you want to refer to font size.small. If we didn't use enums, an alternative would be to like store it in like some string and just make sure that nobody else uses this string for something that like doesn't represent this enum. But a good way to keep it organized is to create this object. And so you can do font size.small, medium, large, or any other case that you add in here. Actually, I don't think you need to you can also do like this, right? XL. Yeah, this works too. You don't have to have them all on the same line. But we'll take this out for now. But what happens here is that whenever you want to, so like let's say we want to print out the font size that you're using with a function. So like the function takes in an object of type font size, which is this enum, and it matches to, you want to print out like if it's small, you want to print out I'm small, right? And so cool syntax for this is you can switch on whatever that enum object is, or enum variable is. So what switch does is it breaks that enum into every single possible case, and you give a handler for each case. So you're saying here, if the case is small, then you want to print out I am small. Same thing for medium, same thing for large. But let's say we wanted to add X large. What will happen is that because we don't have a case for X large in here, if we were to call print font size on .x large, this would crash because we just don't have any handling for it. So one of 2 things we can do. We can either give the actual case. Oh, what the? Why is this not doing anything? Kidding. We can either do this, or another way we can do it, I'll just add in. Another way we can do it is give a default case. So like let's say we had like XXL, XXXL, a bunch of different cases, but we like, if it's anything above large, we just want to print X large, then default case will handle every single other case that we didn't explicitly handle. Yeah, and so this will pretty much large font size. Yeah. So this will print out I am X large. Large font size will print out I am large. What do you think will print out if I do dot XXL? I am X large, correct. Yeah, so it'll just default to this variable. How are we doing on time? Dope. Yes? There isn't too much else. Oh, yeah, let's go to the survey. So yeah, that's, I guess, a good recap on Swift syntax. Does anybody have any questions? I kind of like burned through a lot of that. All clear. You guys can also definitely ask questions on Piazza. We have TAs here as well. Good opportunity. But if there are no questions, where's the survey link? Where's the presentation? Oh, so for office hours, is it on here? We want you guys to fill out this quick 1 minute survey to find out when will be the best time for your guys' for us to hold office hours. Oh, is it in this QR code? Oh, that's dope. So yeah, just scan this QR code and fill out the survey. I promise you it'll literally take 2 seconds, but this will help us figure out what times are best for you guys to hold office hours, and we'll hopefully cater to as many people as possible. We have 10, 12 TAs, and we'll nag some more people if we really need to. Oh, sorry. I'm all over the place. But yeah, fill this out. Is there anything else we want to go over? Oh, project 1. If you go back to the Git book link, that's pretty much where we'll have everything.
Yeah.
And the project 1 will be uploaded to that. It's going to be a small project to get you more familiar with Swift syntax. It's going to be a similar structure to what we just went over. But yeah, it is due Sunday. Definitely not on. Is it due on March? Oh.
It's due after February break.
It's due after February break. So please have a good break. Fill out the survey. It doesn't work. Yana.
Earlier. The limit hasn't reached.
Oh my god. Wait, I'll find the link right now. Where's the link? Oh, Yana, you have a link.
I have a link.
I don't want to open up my messages. So please don't send it to my messages. Oh, I'm gonna cough.
And just for reference, for office hours, the assignments will tend to be due on Sunday at 11:59 p.m.
Oh yeah, it's very good reference.
Well, I have 14 responses.
But we reached the limit, bro.
All right.
Oh, that's so cool. You can shorten it.
I don't think people want to type it.
Just
Just give me
fuck.